Okay, in this section we're going to go ahead and look at the examples that was given on the worksheet on using quadratic formula and discriminants. The most important thing you want to remember in terms of using the quadratic formula is that you have to make sure that your quadratic equation is actually set equal to 0, or else it's really hard to find those x-intercepts, because that is the easiest ones to go find when it's set equal to 0. So the first thing I'm going to do here is actually move all of the terms next to x squared. Now you could move x squared instead. It's really up to you what you want to do with this. So remember, from here you want to identify your a value at this point, because now it is set equal to 0. So a is going to be the coefficient next to x squared. Your b is going to be the coefficient next to x. And your c is going to be the constant that's there. Once you have that, you want to go ahead and plug it into the quadratic formula, and remember you want to memorize this. So if I do plug it in, it pretty much looks like the following. We're going to go ahead and simplify this. So the first part, it's a negative and a negative, so that becomes a positive 6. The second thing is to square the number negative 6, so that gives you 36. And then the next part is to multiply. You have to, it might be easier if you actually take it as a negative 4 rather than thinking of it as a subtract 4, but then your signs won't get mixed up. So I'd take this as a negative 4 times 1 times 4, which is going to be negative 16, and then over 2. And if we simplify the root now, so that means 36 minus 16, that gives you 20. And then again, we know from our studies from the previous section, 20 has a perfect squared factor, so it'll become a, let's see, 6 plus or minus 2 square root of 5. And at this point is to make sure that this whole fraction is simplified. So remember, you have to make sure that the first term, the second term, and the one on the bottom all have a common term in order to reduce this thing. So in this case, since 6 and 2 have can be divisible by 2, the 6 will become a 3. The 2 square root of 5 is just square root of 5. And of course the 2 becomes a denominator of 1, which we really don't have to write that out. So it'll just be 3 plus or minus square root of 5. So here's another example, and again you can try this on your own. Again, we want to set this equal to 0. So in this case, I'm going to subtract 2x and subtract the 3. And at the same time, I'm going to put this basically in descending order by the degree. So it'll look like negative 5x squared plus 5x minus 7 equals 0. Now I can go ahead and identify my a, my b, and my c, and then plug it into the quadratic equation accordingly. And again, I'm going to go ahead and simplify the first term. The next thing is to square the number, then multiply negative 4, negative 5, and negative 7, and then simplify the denominator. And again, we're going to now simplify the radical. You can see that this will be an imaginary number, so let's pull that out. And pretty much, since we know that this term here is divisible by 5 here, we can go ahead and divide that out, but because this one doesn't have a factor of 5, then we can't reduce the first part. Again, you have to make sure you reduce all 3 parts. So you may leave your answer like this, or you could separate them, and then that allows you to actually okay, let me go back here. But again, you can take out that negative sign from here and divide that part there, since the plus or minus won't make a difference. But you also can separate it by writing as 1/2, because you could separate it into 2 fractions, and 5 over 10 is 1/2, plus or minus I square root of 115, if you can see that, 115, all over 10. So that's another way that you guys can actually write that. Now for the discriminant, remember that's just the definition of the actual term inside the square root. So we're talking about using the b squared minus 4ac. And so again, we want to make sure that the quadratic equation is actually set equal to 0. So that allows you to identify your a, b, and c. So on the example that's on your worksheet, this is what I have. If I go ahead and plug it into b squared minus 4ac and substitute in the numbers that I could substitute it with, I get the answer, let's see, 48. So since 48 is positive, that means that this actually has two real solutions. And graphically, we understand that if I do draw this parabola, that means that it actually crosses the x-axis twice. And so that would represent the two answers that you guys have after you finish off your quadratic formula. So here's another example. Again, make sure that it's set equal to 0. That way you can identify your A, B, and C. If you go ahead and plug it into the discriminant and go ahead and simplify that, we find out that this one particularly gives us a 0. So what that tells us is that you only have one real solution, because that means that you're not really adding or subtracting anything as a second term in the quadratic formula, and which means that graphically we're talking about having the one answer cross the x-axis once, which actually is your vertex, and that happens to be on the x-axis. And the last example you have here, again, make sure it's equal to 0. In this case, it's not, so let's go ahead and move over those other terms to the left-hand side so that now it does equal to 0. And now you can go ahead and plug in your numbers after you identified your A, B, and C. And in this case, we end up with a negative answer, which tells me that this one has two imaginary solutions. Because again, if we go ahead and put that negative 108 back into the quadratic formula, we know that when you square root a negative number, it is considered to be imaginary. So again, all that means is that when you graph this, it doesn't actually hit the x-axis. So it may be somewhere like right here.